So for the dipole antenna, we had the driven element was always divided at the center. So we had a wire element and we had a second wire element, and we divided it in two. And for a half-wave dipole, this whole thing was lambda over 2, which meant each of these individual sections were lambda over 4. Well, an interesting effect occurs when a single wire of length lambda over 4 is placed near a ground plane, and it will exhibit the same radiation pattern as a half-wave dipole. The ground plane here will actually serve as to image the other half of the dipole antenna, and it creates what we call a virtual dipole. The radiation pattern, again, it's identical to the half-wave dipole, but the actual pattern that would be developed by this antenna is cut in half. So you would just picture half the bagel, the top half of the bagel, not the bottom half. And no field actually exists in the ground image. So some common examples of monopole antennas, and the reason I bring this up is that that's what happens on a cell phone. It's using the Earth as the ground plane, and your car antenna does the same thing. These are typically quarter wave monopole antennas, which is just half of the antenna with the other side of the feed connected to Earth ground, right? The radiated power and the radiation resistance for quarter wave monopoles are half that of the dipole. So the radiated power for a quarter wave monopole is 18.3 times the square of the driving current, and the radiation resistance is 36.5 ohms.